I'm Anil Kumar, sharing with you few questions from previous test paper. It is quadratic functions, maximum and minimum problems. Well, my grandson scribbled over it, so I rewrote these questions and then I'll take them one by one. Here are the questions. You can actually pause the video, copy these questions, and then solve them. Once you have solved, you look into my solutions. So question number one is straightforward. We are given four different types of equations. The whole idea is I've included decimal numbers, fractions with positive and negative, and you need to find the value for maximum and minimum. So basically it's completing the squares, find the vertex. Now we have a word problem here, which is regarding sum of two numbers. Find numbers if the sum of their squares is a minimum. And then we have another word problem which is very popular regarding the fence, right? So we are given an enclosure with a partition and perimeter of 600 meters. You need to find dimensions which will give largest area. And the last question is kind of difficult. So I'd like you to actually pause the video and copy the last question properly. Try to solve it. You might get answers in decimals. Calculations may be tricky for this particular question. The whole idea here is to work with numbers which are not so easy as you normally get in examples. In tests, sometimes you may land up with questions which will give you values. Sometimes you think they're wrong, correct? So this question is going to help you gain some confidence while solving such questions, correct? So now let's begin solving them one by one. I've taken the first equation with fractions. Let's work with these fractions. Find the vertex to find maximum or minimum. Now if you observe, leading coefficient is positive. Positive means the parabola is going to open upwards. So it's a parabola which opens upwards. So we are looking for minimum, right? We are given equation as f of x equals to 3 over 2 x square plus 4 over 3 x minus 1 over 3. First step is always to factor the leading coefficient. We'll keep the third term, which is constant, outside, right? So we get here 3 over 2 x square plus, so when you factor 3 over 2, what should become 4 over 3? Let me rewrite this as just 4 over 3 times 2 over 3, right? 2 over 3. Now, if you open 2 over 3, 3 over 2 will cancel. You will left with 4 over 3x, right? So that ensures that whatever we've done is perfectly fine. Leave some gap and write this number away. We'll use it only at the end, right? Follow these steps. And also note, I'm using square brackets. It is advantageous. So the next step is we'll again write 3 over 2 and we have x square plus, so that becomes 4 times 2 as 8 and we have 8 over 9 x. Now what is half of 8 over 9? Well, half of 8 over 9 is 4 over 9. So we'll take 4 over 9, square it, add and subtract the same term, which is 4 over 9 whole square. Doesn't make sense to you. And we'll keep this minus 1 over 3 away. Now these three terms form a perfect square, correct? So we could write this as x, positive sign from here, 4 over 9. Let me write like this, whole square. Square of 4 over 9 is negative sign, 16 over 81. And we have minus 1 over 3. Let us now open the bracket. So once you open the bracket, you get 3 over 2 times x plus 4 over 9 whole square. You have to multiply 3 over 2 with this number, correct? So let me write this as first 3 over 2 times 16 over 81 and then we'll just write minus 1 over 3. So that gives you 3 over 2 x plus 4 over 9. Now you can simplify this. That goes 8 times. We get minus 8 in the top. And 3 goes 27 times, correct? So we just simplified this, cancelling 2 8 times and 3 27 times. Minus 1 over 3, correct? Now we have to combine these two terms. Both are negative. They get added up. So we could write this as 3 over 2 x plus 4 over 9 whole square. Now negative of what? So if I write negative outside, I'm going to add them. I'm taking common denominator as 27. 8 plus, this is 9 times 3, right? So 8 plus 9, correct? So that gives you the final answer, which I'm going to write on the right side, and then we'll write maximum or minimum. So we have this function f of x written as 3 over 2 x plus 4 over 9 whole square and minus 8 plus 9 is 17 over 27. Now these values here will give you the vertex, since we know that it opens up, and therefore we have minimum. And minimum for x, the value is whatever makes this 0, which is minus 4 over 9, and the y value is this value, minus 17 over 27, or you can say that the vertex is at minus 4 over 9, minus 17 over 27. So I hope the steps are absolutely clear. That is how, if you do in steps, you should be in a position to answer all the questions, right? So I hope that helps. Now let's move on to the next question. The next function for us is f of x equals to minus 2 over 3x squared minus 4x plus 16. So let's rewrite the function, which is f of x is equals to minus 2 over 3 x squared minus 4x plus 16. We need to find maximum or minimum. Negative means that the graph will be opening downwards. Therefore, we expect maximum, correct? So we'll follow the same technique, completing the squares, taking minus 2 over 3 common, using square brackets, x squared, minus and minus becomes positive. Sign has to change, right? 4 times 3 over 2. X, and we have plus 16 here, right? Now that simplifies to minus 2 over 3 x squared plus 3 times 2 is 6. We get 6x here plus 16. Half of 6 is 3, right? So we have minus 2 over 3 x squared plus 6x. Half of 6 is 3. We'll add and subtract square of 3 plus 16, correct? So that gives us minus 2 over 3. First 3 terms are perfect squares. X plus 3 whole square minus 3 square is minus 9 plus 16. Open the bracket. So we have minus 2 over 3 x plus 3 whole square. Multiply minus and minus becomes plus 2 over 3 times 9. And here we have plus 16. And that gives us minus 2 over 3 x plus 3 whole square. And that is 6 plus 16, correct? And finally, we get minus 2 over 3 vertex form, perfect. 16 plus 6 is 22. So from here, you can read and write your answer. So in the vertex form, what we get here is f of x is equals to minus 2 over 3 x plus 3 whole square plus 22. So that means the x value or the points are minus 3. That will make this 0, and the maximum is 22. So we have maximum value of 22 at x equals to minus 3. So this is another way of writing the answer, right? So I hope that is absolutely clear. Now we'll take up the next question here. Now in the next question, we have some decimal values. I'll use calculator here. So we could write this function taking 0.04 as common. So we have x squared minus 2 divided by 0.04, right? So let me rewrite this as 2 divided by 0.04 x plus 513, correct? So we have 0.04 x squared. So let's divide 2 by, so 2 divided by 0.04 gives us 50. Right? So it becomes minus 50x plus 513, correct? Now, see, 0.04 could be written as 4 over 100, correct? 4 over 100, and then it is 2 over 50, that helps, correct? So 50 over 2, perfect. Anyway, let's continue. So what we get here is x squared minus 50x, half of 50 is 25. So we'll add and subtract square of 25 plus 513, and that is 0.04 x minus comes from here, right? Minus 25 from there, whole square, and minus 25 square is minus 625 plus 513. Now let's open the bracket. We have 0.04 times x minus 25 whole square minus, let's calculate this value. So first let me calculate 25 square. So 25 square is equal to 625, multiply by 0.04 is equal to 25. So we get minus 25 here plus 513. We have to now combine these terms. We get 0.04 x minus 25 whole square, and let's do 513 minus 25. 513 minus 25 equals to 488. So we get plus 488. So that gives you the vertex is at 25 is the x value, y value is 488. Perfect. Since it is positive, we have a parabola which opens like this, and therefore what do we have here? We have minimum value of 488 at x equals to 25. Does make sense to you, right? So that is how you're going to solve them, correct? So let's take another example, which is simplest of all. So now we could write this as minus 5 bracket x squared, minus means that sign becomes negative, 4 divided by 5 x bracket close minus 2. It's a good idea to use square brackets, right? Minus 5 x squared minus 4 over 5x plus half of this is you can write 2 over 5 whole square minus 2 over 5 whole square minus 2, correct? Get minus 5 within square we got x minus 2 over 5, correct? Whole square. Square of 2 is 4, square of 5 is 25 minus 2, open the bracket, minus 5 times x minus 2 over 5 whole square, minus minus becomes plus, 5 goes 5 times, so we have plus 4 over 5 minus 2. That gives us minus 5 x minus 2 over 5 whole square. So now you can do this, you can take common denominator of 5, 4 minus 5 times 2 is 10. That gives you minus 5 x minus 2 over 5 whole square. 4 minus 10 is minus 6. We get minus 6 over 5. Correct? So from here, we can say our parabola is going to open downwards. Perfect? And therefore, this vertex is 2 over 5 is the x value, and the y value is minus 6 over 5. So we have a maximum value of minus 6 over 5 at x equals to 2 over 5. Perfect. So that is how you're going to solve when the equations are given to you, right? Now we'll take the word problems. Here is a word problem based on quadratic functions. The equation here is the sum of two numbers is 16. Find the numbers if the sum of their squares is a minimum, right? So let us say that two numbers are x and y. So in that case, the equation will be x plus y is 16. That is, sum of two numbers is 16. Find the numbers if the sum of their squares is a minimum. Okay, so first thing is we could isolate one of the variable from here, and let's say x is equals to 16 minus y. So I'll call this as my equation number 1. Now from the second statement, I get the second equation, which is sum of their squares, and we want to write our function f of x as sum of their squares, which is x squared plus y squared. And we want to minimize this particular function. So we'll substitute the value of x here to get value in y. So we could write this function as 16 minus y whole square plus y square. Is it okay? So what we did at this stage was that we sub 1 in it, right? Now we can just expand it. So if you expand, you get 16 square minus 2ab, which is 32y plus y square, and we already have a y square here, correct? So that is what you get, no need of brackets. 16 square is what? 16 square is equals to 256. So I'll write down y square terms first, which is 2y square. And then we have minus 32y, and 16 square we'll write as 256, correct? 16 square is 256. Now it is only to be simplified using completing the squares. So let's do completing the squares. Let me do it right in the center. Then we'll get back to the points. So we have our function f of x equals to 2y square minus 32. So we'll take 2 common. So we have y square minus 16y plus 256. Now half of 16 is 8. So we get y square minus 16y plus 8 square minus 8 square plus 256. Correct? That gives you 2 times y minus 8 whole square. And minus 8 square is minus 64 plus 256, open the bracket, 2 times y minus 8 whole square, minus 2 times 64, so 128, plus 256. And that gives you 2 times y minus 8 whole square. And 128 take away from 256 is also 128. So we get plus 128. That gives you the points, correct, for maximum. Now in this case, you can see the parabola opens upwards, right? Since this value is positive, this parabola opens upwards, and therefore the vertex here shows minimum. So we'll have minimum at x equals to 8. Perfect. This is the value at x equals to 8. Now if x is 8, what is y? Sorry, we have y here, sorry. So at y equals to 8, we get the minimum. So if y is 8, what is x? So we can write x equals to 16 minus 8, which is also 8. So the answer is that the numbers are 8 and 8, right? So both happen to be the same numbers. So I hope that helps you to understand how to solve word problems. Now let me take the next problem. Now here we are given a rectangular area is enclosed by a fence and divided by another section of fence parallel to its width. So let's make a rectangle here. So we have a rectangular area which is divided by another fence which is parallel to its width. If 600 meters of the fence is used to enclose the largest area, what are the dimensions of the enclosure? So let us assume that width is W and L is our length, right? So in that case, perimeter will be 2L plus 3W. Perfect. We are given perimeter as 600. So we can write this as 600 equals to 2L plus 3W. Now we can relate one variable in terms of the other, right? So let us write what width is in terms of length, right? So let's write down width in terms of length. So we get 3W equals to 600 minus 2L, or width is equals to 600 minus 2L divided by 3. We want to enclose maximum area. What is area? Area is length times width in this case, right? So length times width is 600 minus twice length over 3. So that becomes an expression. So what we see now is an expression in one variable, length. Sometimes we also write this as A as a function of length is. So if so what we get here is 600 divided by 3 is 200. I could write this as 200 length minus 2 over 3 L square. That's what we get. So if I rearrange, I get minus 2 over 3 L square plus 200 L. We'll again complete the squares to solve. Taking minus 2 over 3 common, we get L square minus 200 by 3 over 2. Is that okay? 3 over 2L. Now that gives us minus 2 over 3 L square minus, that gives me 100, so 300L. 300L. That is 2 over 3 L square minus 300L. To complete the squares, we'll add and subtract half of 300 square. So we have this term. Perfect. And finally, we can write this in the vertex form as, let me take one more step. L minus 150 whole square minus 150 square. So let me write down what is 150 square. 150 square is equals to 22500. So let's open this bracket and write it here. So we have area as a function of length as equals to minus 2 over 3 L minus 150 whole square. Minus minus becomes positive. 2/3 of 22,500. 22,500. Correct? Now clearly from here, maximum area will occur when length is 150. Correct? Okay. Let's analyze. So when L equals to 150, we get maximum area. Maximum because negative sign indicates parabola is opening downwards. So we have maximum at L equals to 150, which will make this 0. Perfect. So if L is 150, what is the width? Width is 600 minus 2 times 150 divided by 3, which is 600 minus 300 divided by 3, and that is 100, correct? And so we get our dimensions. So the answer is, the dimensions are 150. The units in this case are meters by 100 meters. So that is how it can be solved. So I hope the steps are absolutely clear. Let's take up the next question, which is also the last question of this set of videos. Here is the word problem based on quadratic functions, maximum, minimum. The question here is, last year 250 tickets at $5 were sold for a dance event. At this year's dance, special paper used for the tickets costs 8 cents for every 4 tickets created, and the DJs are contracted for $875. How much should each ticket be sold to maximize profit based on a survey that for every 10 cents decrease in ticket price, 8 more tickets are sold? You can pause the video, answer the question, and then look into my suggestions. We want to maximize profit, right? So profit is based on revenue and cost. In short, I can write profit as revenue minus cost. Now in our case, what is the revenue? You get revenue by selling tickets. So here we are given that revenue should be, last year 250 tickets were sold when the ticket price was $5, and a survey says that for every 10 cents decrease in ticket price, 10 cents from 5, 8 more tickets are sold, right? So number of tickets increased by 8. So we could get revenue as 250 plus 8 more tickets for every 10 cents increase. So that becomes the number of tickets at the cost of $5 less 10 cents. Let me write 0.10 n, number of 10 cents. So if you decrease by 1 10 cent, 8 tickets extra will be sold. If you decrease by 20 cents, 16 extra tickets will be sold, right? Now let's talk about the cost function also. Cost is a fixed cost which is going to the DJ, which is $8.75, and then the cost of printing tickets, which is how much? 8 cents for every 4 tickets, right? So 8 cents for 4 tickets, that means 2 cents for every ticket, right? 2 cents for every ticket. Number of tickets are these. So let me write cost here. Cost is 2 cents, which is 0.02, 2 cents for every ticket. Number of tickets will be 250 plus 8n, right? So that becomes the number of tickets, 250 plus 8n. Profit is difference of these two. Correct. We can simplify this a bit. Multiplying by 0.02 times 25 will give me 5. Right? 2 times this is 50, 2 decimal places. And 8 times will give me, 8 times 2 is 16, so plus 0.16n. Right? So that becomes the cost plus 850, I forgot to, 875, which I forgot to add. Okay, so let me add this cost of DJ. So this is per ticket. Cost of DJ I wrote here 875. Let me write here 875 plus this. So plus 875. Correct? So that becomes the total cost. 875 is for the DJ, and that is the cost for each ticket. 2 cents. Number of tickets expected to be sold will be 250 plus 8n. So we will multiply that by 2 cents. Correct? So that becomes the cost. Now we can write down the profit as difference of these two. So profit will be, you have to multiply these quantities. Let me rewrite. 250 plus 8n times 5 minus 0.1n. Take away the cost, which is 875 plus, when I opened it, I got this result, which is 5 plus 0.16n. So let's do. So if I multiply 5 times 250, I get 1250 minus 0.1n will give me 25n. 8 times 5 is 40 plus 40n. And 8 times this is n squared plus minus 0.8n squared. Now if I open this bracket, I get minus 875 minus 5 minus 0.16n. So as far as n squared is concerned, we have minus 0.8n squared. N values, there's these three. Let's combine them. So 40 take away 25 take away 0.16 equals to, in decimals, 14.84. So plus 14.84 n. Constants are 1250 minus 875, okay, minus 5. That gives us 370. So that becomes the equation for the profit function. To maximize, we'll do completing the squares, right? So we could write this as minus 0.8 common, n square minus. So let's divide 14.84 by 0.8. We get, in decimals, 18.55 n, right, plus 370. To maximize, we'll complete the squares. We get minus 0.8 n square minus 18.55 n. Half of this divided by 2 in decimals is 9.275. 275 square, take away 9.275 square plus 370, correct? Now that gives us minus 0.8 n minus 9.275 whole square. We can open this bracket. Multiplying these two, we get plus. So we'll square 9.275 and multiply by 0.8 with positive sign. So let me square this first. And then times it with 0.8. And that gives you a value which is 68.82. And then we'll add this to 370, right? So that gives us minus 0.08 times, we already opened this up, so let me close this bracket here itself, n minus 9.275 whole square, and let's add these two, 68.82 plus 370, 438 plus 438.82. So that becomes the profit, and for n the value is 9.275, right? So we can maximize the profit when n is equals to 9.275, correct? Now if n is 9.275, we have to find the cost of the ticket, correct? Now it says how much should each ticket cost? So let's calculate cost of ticket. So cost of the ticket is $5 less 0.10 times n, and n is 9.275, right? So that gives us, actually I should round it to 2 decimal places, right? Anyway, so it gives me 5 minus, so when I do it like this, it will be 0.1 decimal movement, right? 9, let's say 9.3. So 5 minus 0.93 is equal to, in decimal, $4.07, correct? So to be precise, the cost should be $4.07. You understand how to solve such questions and write your equation. So the idea here is that as per the survey, for every 10-cent decrease, 8 more tickets are sold. So you get your revenue. Cost is based on fixed cost and cost for printing the tickets. So we are assuming that we are only printing the number of tickets which are same as being sold. So we are assuming that number, this should have been 250 plus 8n. So what did I do? 250 times 0.02, I get 5. Okay, so that's good. So I got 5. So I calculated with 250 but wrote 25. So you get 5 cents. That's correct. So that is how you can get the cost factor. Profit is revenue take away cost, and then you have to complete the squares to get the value of n. N should be rounded. So it could have been rounded to 9, for example. In that case, we get $4.10. So you could round this to $4.10, right? So that will be our answer. So I hope this exercise helps you to understand how to apply completing the squares method to find maximum or minimum for a quadratic function and in a real life situation. So in any equation, if the leading coefficient is negative, parabola is going to open downwards and you are getting a maximum. If leading coefficient is positive, then we'll get minimum, right? As we got for the example, one of the first 4 examples with positive leading coefficient. I hope you understand and appreciate what has been done in this video. Feel free to share your views and comments. And if you like and subscribe, that'd be great for me. Thank you and all the best.